Thanks, Eduardo. So I'm going to go ahead and share my screen. And so we'll be doing Level Up Your Python. The links are here. So if you want to open up the notebook, you can either click the direct link I gave there, or you can go to the repository, which is this one. And what we're going to try today is a little bit different. I want to try going into the WebAssembly version rather than the Binder version. But if that doesn't work, I have the Binder version as a backup, as well as I also have it running locally just in case. But if you just click on that, that will take you to the notebooks, and they're running in WebAssembly. Also, just to point out, and this is true generally for any sort of packages or things that you see that you find useful, try to remember to give them a star on GitHub. It's just a nice social thing to do. Okay. Also, if you go to my website, which is icinumpy.dev, I have links to all my material there, and the Level Up Your Python is right here. That will take you to the most recent version. Okay, and then just to point out, this has been tagged, so if you want this exact material, it's available under this PyHEP tag. We're going to start with an introduction, which is an introduction to me as well. And you'll notice a few of these special cells that are here just for the WebAssembly version, so make sure you run those if you see one. Okay, quickly about me, I'm a member of IRISHEP. I'm admin for PsychHEP. I'm part of the Python Packaging Authority, and I'm also working on Scikit build. And I do a variety of things, but we don't have enough time to talk very much about those other things. I just do want to point out that this is fairly... Somebody might need to mute, or is that a question? Please do questions in chat or in chat or Slido I have open, and then of course the Slack too. Okay. So I just want to point out that just want to change to make that editable. I do want to point out that we'll be covering a lot of different material. The idea is really just to give you an idea of what's available, not to necessarily carefully teach you each thing. I'm just doing too much, and there's probably a very wide range of different skill levels here. Also, I'd like to point out that new features in programming are really about restricting things that are possible rather than enabling new things, and that's a good thing. For example, a goto, which is a much more powerful and general statement than, say, a for loop, allows you to do pretty much anything you want, but it's practically unreadable because you can do anything you want. So someone looking at this code would have to look through the entire piece of code to see see where the label is, to see where the goto is, to figure out what's happening to triggering that label, and to realize, oh, this thing is doing some sort of a looping structure. Whereas the actual syntax feature for it, once a programmer sees this, they know exactly what's happening. This is a looping structure, and they don't have to think anymore about details. They just know this is going to run 10 times. And this is really how many of these features will work, especially when you go through our sequence of features. Yes, you could have done this without the feature, but the feature is easier for programmers to read. It's something that everybody can learn, whereas any code you write, everybody has to read it in order to understand what you're trying to write. Okay. We've restructured this class a little bit. If you go to the web version, the website version of this class, just to point out, it is the link here. You'll see a new structure, which is the one you see on the left. The notebooks here are still the old names, unfortunately, because I didn't want to break URLs quite yet. So at some point, I'll go ahead and break URLs, but we'll have to jump to slightly unusual numbers, but I'll point them out when we go there. So first, we're going to 1.1b, which is the new 1.1. Okay, so we're going to start our journey with an introduction to classes. And I'm going to try to introduce classes a little bit, maybe a little bit differently than what you've seen done before. And we'll see how this works. All right. And I'm going to go ahead and make text a little bit bigger, but I'm going to mostly be playing over here. Okay, view presentation mode. Oh, there it is. Okay, and then let's just open up an empty notebook. All right, so quick introduction to classes. If you are already familiar with classes, feel free to jump over to the to a couple of the advanced sections, which would be 1.1 and 1.2 classes, which we'll just cover the general introduction today. And so everything in Python is an object. And this is true for anything that you can assign or play around with, anything that's not syntax, it's an object. And objects, an object is really just a collection of data and functions. So for example, if we had a object representing our home directory, we could make an object that had some sort of string location, and then we could stick some sort of a function. This is just imaginary syntax because we're not quite to where Python is yet. So we could stick this function inside home directory, we could stick this string inside home directory, and then we have an object that represents our home directory. And it even has this handy method that, oops, I like double clicking, sorry. It has this handy method that checks to see if it exists or not. So we could make a home directory and then ask if our home directory actually exists. But if this is just a single of these is not that interesting. What's much more interesting is if we have many of these representing different directories. And if we do that, then it becomes a little bit ridiculous to have to add this function to every single one of them. Unless, of course, you're writing JavaScript, which is exactly how you do it. But all of these are the same. So what we can say is, well, let's make a class. So we're going to add one extra element to this picture. So now instead of just an object, we have a class. A class is simply the template that produces objects. Okay, so here's our little class. Now we're finally actually in Python. Let's go ahead and just run them over here. So we have a class called path. Now to create a new one of these things, we can just type path and then give it some sort of path. Doesn't bin. And this creates this path object. We don't have any sort of special representation for that. That's just the default that Python gives us. But that's fine. We're just doing this in pieces. So we can go ahead and assign that to user bin. And then user bin.exists. And it does not exist. Here. Okay. Just because I want to think about how my Mac is structured. Okay. And then, so what we've done, this init is a special method in Python. Special methods are called dunder methods, are ones that are reserved or expected by Python to do various things. In this case, whenever we create a new path object, it creates it by calling this init. It creates a new object, and then it calls this init on that object. It passes that in as self. And in our case, we asked for an extra string location, and that simply gets stored in the object itself here. Okay, so the object itself only has this one method. So if you look at its dict, which again is another dunder name, you'll see that the only thing stored inside this is the string location. Okay, it's not storing this method. When you ask for a method on an object, it will check to see if it exists in the object. If it doesn't exist in the object, it will then look in the class. And it finds it in the class and it calls it in the class. Okay, so we have, just to point out, we also have user bin dot string location, and that's there. So that's the idea of a class. And this gives us another benefit. If we're actually working with these objects, then we want to be able to assume that they have all of these things. It's very inconvenient if one may have string location, one may have just plain location. if they have different methods. We want to just assume that they always have these things. So class gives us a way to reason with the objects. We have a path, we know we can call exist, we know it has a string location. Okay. Just to mention that this lookup, let me just show you this one. So I said it looks up in the class. Well, a class is called under class. As Jim points out, is a double underscore, a shorter way to say that out. If you look at the class, this is the class, and I can now look at its dict. And there's some stuff here, but that is the method. So this version exists, and that's that function. So that's the lookup mechanism. Now, we won't really go into this too much, but just to mention, this is actually very trivially extendable to account for subclassing. So with subclassing, that says, well, if you make another class or you make any class and you stick something in here, a different class name, so I could be like old class. Well, all that really does is it means that it just adds this to the lookup mechanism. So it checks the object, then it checks the current class, and then it just starts checking all of the parent classes, all the things that are here. So you can chain classes together, which is really useful for saving, for avoiding repeating yourself if you want to make different variations of things. Like you could imagine a class being cat, and then that being its parent class being animal, etc. Okay. If you want to see what the actual lookup mechanism is, then the MRO, or method resolution order, is where that is, and that just says path. And then at the end, the very last thing is always object, because every object in Python eventually has object as the final lookup. That's the reason that there's a string representation here that's actually in object. Okay, but this is a bit cumbersome. We have to repeat ourselves quite a bit. It's also kind of weird if you're coming in from a different language like C++. You may sort of expect something that looks more like this. In C++, you can specify the members of the class in the class definition, and that's also the only members you're allowed to use. In Python, you can stick any member anywhere because obviously we didn't specialize them. So we didn't tell it that that's going to be the only thing. So I could take my path, what's it called, user bin. I can just assign anything, and that just works because they're basically just a bag of data. So, but it would be nice to be able to write something a bit more like this. I'm not sure what we put. Well, this is probably the same thing as. Yeah, this is the same thing as before, but not quite sure what to put here. But we'd really like to have a syntax like this, specifying all of this is fairly verbose. And one of the things I think that causes people to really think writing classes is a little bit hard. So let's try this a different way. And there's actually a tool that was added in Python 3.7 particularly, called dataclasses. And it's part of the standard library. And it gives you a new syntax for writing classes. Now, the first thing you do in data classes is you put a decorator on your class. So classes.dataclass. We'll talk about decorators in a little bit, but for now, let's just say that this is something you stick on top of your class, right? Class path. Again. Now, this time we will write. Actually, let's give it a different name called data path, because I want to compare the two. Okay, so this time what we can do, instead of writing out an init, we can just put what we wanted to put in the first place. We can say string location. Now in Python, you have to either assign it to something or you have to give it an annotation. In this case, we'll just annotate it with a type. Doesn't matter what I put there. It's just because I have to somehow make this thing a valid piece of syntax. And then I can just grab our old exist function because it's the same thing we already had. We'll do that. Let's make that slightly prettier. All right, let's look at our data path. Okay, and if I do that, you'll see that not only does that work like before, but I actually get this nice representation for free. I would have had to have written that manually if I was using regular paths or regular something regular. Let's see if I just do user if that exists. This is because I'm in WebAssembly and that doesn't have access to my file system. That's why. Like, why is that not working? It worked before. Okay, so this is actually quite correct. Okay, so that's data classes. We get init for free. It turns out we actually get a lot of different things for free. We get an init, a repr, which is the representation of the class on which is what you saw right there. We get equality for free, which actually works really nicely for this. And very easily, we can activate several other features, especially in Python 3.10. Lots of new features got added. I really like data classes in 3.10. But we can, for example, make the class frozen. For example, we really shouldn't be changing these string locations. Once we make an object, it should just always refer to the same path. Then we could do that really easily just by saying frozen equals true. So these options are added right here on the decorator. So I could say order equals true, which will sort them alphabetically. Which will allow you to sort them alphabetically, sorry. And I could even say frozen equals true. Yep. And then now we can't change it afterwards. Let me just scroll down a little bit here and show you for example, the sorting inequalities. It's right here. Okay, so we're going to go ahead and move on, but that's sort of a quick introduction to classes and data classes. I think data classes are a very nice addition. You kind of have to think a little bit differently. So it's a little bit harder if you've already been using Python for a while. They may not be quite as, they may take a little getting used to, but they're really quite nice, especially for certain types of problems. They are fantastic. If you like data classes, but you want a bit more, adders is a fantastic library. It's the one that inspired data classes. It came directly from there, from adders. And catters is a really good way to convert things in and out of data classes, because once you have this declarative structure for writing things, you can actually talk about, well, if I want to convert them from JSON or to JSON, then that can be entirely separate from the class definition. That can be part of a converter, which comes from catters. And they know how to inspect data classes and convert them. So there's actually a built-in converter to JSON and things like that. It's quite easy to add your own. And then there's also Pydantic, which is sort of, these are really nice and individual pieces, and you can mix and match them, catters and adders and data classes. Pydantic is sort of an all-in-one solution that's about inputting and outputting structured data. So, but it does lots of things for you. Like it automatically assumes that if you have a number, you have a string 2, that's the same thing as a number 2 and stuff like that. And it actually looks at both catters and Pydantic will look at these annotations and it will try to actually convert to whatever this is, which is one, besides documentation, this is also a good reason to have good, if this is a string, to go ahead and call it string. Okay. And just to mention, using classes, we saw these methods and they pass these self. Okay. So let's go forward to inspection. All right, and I'm going to go ahead and just close a few of these other windows. So this is section 1.2 inspection. It's got a little WebAssembly thing, so please run that if you're doing the WebAssembly. If not, it doesn't hurt. Okay, so Python has very powerful inspection tools. There's lots of different ways to inspect what you have. Oh, just a second. I do have a question. My Zoom was partially covering the window. Sorry. String location. Well, somebody asked, will string location be the same for all objects of a data class? So the special thing data classes do. Very good question. The special thing that data classes do is open this back up. This thing, so what this decorator does is it inspects all of these and then it turns them into instance variables. The way that, So this is sort of written the way you might expect it from, say, other languages or a very nice declarative style, but it inspects this and it creates something that looks just like this. So it actually does an init, a repr, and a EQ by default. And it generates the input values, it sets them equal to here. So this is considered, and this is just a general thing, whenever you write an annotation like this directly inside of a class, it's considered to be an annotation on instance values rather than class values. So it will do the right thing for you. If you're actually doing typing, which I'll briefly mention typing before, then the way you would actually tell Python that this is on a class, well, first off, you really should set it equal to something, because it has to be this, or it's going to be the same on all of these. But there's no, this is not going to get constructed later if you're actually trying to stick this something that's the same on all classes. But then you can do typing class var, and that specifically tells the typing mechanisms that this thing is intended to be a class variable and not a instance variable. And data classes will pick up and understand this, and it will not create anything for this in this case. So that would create, so then every single one of them would have a string location that's thing, and they would all be stored in the class, and there'd be only one of them. Whereas if you do this, then data classes will process this, remove it from the class, and add it to the instance. Each instance will have a brand new thing default by, that'll be the automatic default. Okay, good question. So going back to inspection. So here I'm writing a function. We're going to try to inspect it. I went ahead and added type annotations here. So I'm expecting it to take a float. I'm returning a float. Those are just annotations. They're not Python. They don't change Python at all. They're basically documentation, but very good documentation, and documentation you can check manually. Then you can call help, and that will show you this, the help on the function. And notice how our annotation is right here. So this, our doc string. So this string is special. The first string in a function is a doc string. It'll include the annotations. So the user can see that I'm expecting floats and returning floats. So I said I could put an int in there and it still works. That just tells the programmer, as well as some various tools, that I'm expecting a float. I can also do f dot tab to see what's inside there. There's actually nothing inside of a function, but if I do an underscore, then I can see all of these dunder things. So you see Python has all sorts of dunder methods on functions. Okay. I can also look inside it using the dir built in. So I can say dir, and there's, again, list of all of the different things that are inside. So I could call f dot annotations, and that would actually show me the annotations. X is a float, return it, the return value is a float. And a cute trick of the syntax, that's actually a keyword, so there's no way for it to actually be, there is no, you can never pass this can never be returned, so it's a safe thing to put for this. Okay. There's also an inspect module in Python. So if I do inspect.get source file, that will tell me the source file, and go ahead and run that. And this is the source. There is no source file. This is just an IPython creates a source file for you. But I can actually get the source. It's a real file. And if I do inspect.get source, you'll see the source for the function. So there, you can't always grab the source of any object in Python, but you can get a lot of them. It's definitely something that's very handy to have on the inside of a notebook. I would not build this into a library somewhere, because there are ways that the source file might not be available. You could have a PYC file and then delete the original .py file, and that's still valid, but there is no source file. You could be running off of inside of a zip file in a zip app, and there might not be, the source file might not be accessible, but the import system still works. But still, this is very, very handy to have. There's also a tool in Rich. Rich is a really nice library. We'll be seeing it several times. The Rich library is really designed for rich output on a terminal. So it has all sorts of great stuff for terminals. You can format all sorts of different ways. but it has some really handy tools in it, including this inspect. And for some reason in WebAssembly, it doesn't realize that the WebAssembly can support color, but that's fine. It's still quite nice. So for example, if I do inspect, you'll see that I get this sort of a little bit more nicely formatted version of this. It'll also be in color if you're in a normal notebook or on the terminal. And there's a bunch of different things that you can add to this. So I could say, well, first off, I can see what's available by saying inspect. So let's just do inspect, which inspect. So we see we have a variety of different options here, and they're described. You've got this nice description here, and you can see, for example, methods equals true. You want to see methods, so I could say, or dunder equals true, because remember we said this doesn't have any regular methods. Equals true. That will show me the dunder methods. So now I've got a bunch of dunder methods there, which is really long. We'll do something else because the built-ins is long. We could do private equals true. We could see all equals true to see all attributes. There's really a lot of great things there. So for example, I can inspect the number 3. And we could do all equals true. And there we go. We have all sorts of information on what's stored inside numbers. You see the regular methods as well as the dunder methods. Okay, so that's inspection, the very, very powerful inspection tools. It's really important in Python to be able to go see the source. It's open source, and that's one of the things that makes it powerful. Okay, we're going to jump to logging now, 1.3. One person did ask a question: if data classes adds another syntax to making classes, and isn't this making it more difficult to learn Python 2 ways of making classes instead of 1? And well, anytime you add something, it adds 2 ways to do something instead of 1. The new way of doing things is more restricted. So in a data class, you're specifically creating a class that has a set of members. Generally a fixed set of members. It's not something you can add and subtract. So there's a lot you can do with classes in Python, whereas doing a data class, you're hopefully restricting yourself to the most common subset of those things. And then it automatically does a lot of things for you. So I did not show you how to create a repr. I didn't show you how to create an equal. I didn't show you how to create I did show you how to create an init, but now you know how to create all of those things without having to know it. So I don't have to teach you all those other special methods. I also showed you just with adding 2 keywords, how you could add the ability to sort your classes as well as the ability to freeze the classes. You didn't have to learn how to create a property and how to hide your values and properties, things like that. So it really gave you a lot of things. But yes, it does create 2 different ways to write classes. Okay. So this is logging. Logging is actually really nice and somewhat underused in Python, especially if people are just sort of starting to write Python. Logging is really, really nice. And it sort of helps with one of the main things you'll see in Python quite a lot, where people are adding print statements to try to debug problems. They then debug the problem, and then they remove all the print statements. And with logging, you actually get to keep the print statements. So this is the logging module built into Python. And we're just going to do set up the basic configuration here. Unfortunately, the logging module is a little bit ugly to work with. It was written a very long time ago and has never been replaced with something better. Because if that case, then there would be 2 ways to do logging. So that's a problem. I'll address the other question in a moment. So this is how you'd set up a basic configuration for it, just telling it, say, hey, I want to output info messages. Okay. And then if I go ahead and get a logger, now you can put any name in here. And the reason that this is sort of looked up by name, and this is a global sort of name that you, once you define, that's all those loggers will match. And that makes it really easy to do this in different in different modules. So this could be the name of your module. That's the sort of traditional thing to do. So let's say if I was writing vector, I could make this vector. And then anywhere you write get logger vector, that will get the same logger. So any settings you change on a particular logger, then that will affect this logger. So in this case, I'm calling mine unique because I guess I could have called it level up your Python. That might have been better. Okay, so now if I do log.warning, that will print a warning. I can do log.info, that will print an info. A debug, notice the debug didn't print anything. That's because I set a level of info. So anything that's a more, that's a less verbose level than info will not print. So for example, if you're debugging, you could just stick a bunch of debugging things here. You could turn on debugging for your logging, set the level to debug. And then, so like that, set your level to debug, you're now debugging. And then when you're done, you can set this back to info, and then all of your debugging statements will disappear. And then if you ever need to debug that same problem again, you just set it back to debugging, you get your verbose printout again, and you're able to debug it much quicker. Generally, if it's really nice if you're doing operations, if you put some sort of debug or even info level messages that describe what you're doing, that sort of let you track the progress of your application, that can be very, very useful. You can turn on and off loggers by name. So you can just turn on or off the, say, debug level printouts for just your logger if you want. Okay. Another really powerful feature of logging is it's integrated with PyTest. So in PyTest, if you add this option, this log level info, log CLI level equals info to PyTest, it will actually record all of the logging statements of this level of say info or debug. You could set this to debug actually if you want. And then if a test fails, it will spit out all of the logging statements too in their own block. And they will actually be info or better, or you could set debug and get debug or better, which could really help you solve broken tests much quicker if you then have a description of what I was doing and you can see where it went wrong. There's other different tools. Somebody mentioned log0. Struct-log is another nice one. That's very good. And Rich actually does have a handler for logs. So if you want beautiful, colorful logs, Rich can do that for you. So you could say from rich.logging import rich handler. This is how, again, I said this has a really ugly sort of weird mechanism. You see the old print formats here and stuff, but that's because this was written back in Python 1 something. But you can set this as make as config. This is a recipe you can just grab from Rich, and you give it this rich handler. And then when you print your log infos, you just use it just like you would do normally. But instead, this will print out very beautiful, colorful, rich printouts. So you can copy this. It does need to be the first call to basic config. You can't set the handlers later. So you could copy this in and try this out yourself, and you get these nice, colorful printouts. You can even set an option here that will do the rich mini language. And then you can even put the rich mini language inside your logging messages and put bold and color and different colors and stuff like that. So it's quite powerful. Okay. And so somebody mentioned log0 as well. And they do log0 does different colors as well. But I'm quite fond of the rich is very, very powerful. So if I want something more, again, you would do this for an application, not your library. Your library, you should just do the vanilla things. You should just do these things. And then the application can actually then can customize it. So that way somebody can choose rich, another person can choose log0 or something else. One quick mention is if you do use, there are ways with logging, if you put an option, something in, so let's say 5% S and then thing, logging will not evaluate this thing if you do not print the log message, which is really nice. There's a trick to get this to work with sort of the nicer formatting with this thing, but it's a little bit involved. You kind of have to wrap the strings with stuff. Okay. Let's stay on the topic of debugging. We're going to 1.4. And with debugging, let's go ahead and add rich. Since we're going to do something, we're going to show a rich example as well. Python has a very powerful debugging system built in, and IPython integrates very nicely with it. So I'm going to write a little bit of broken code So this is an example of a broken code. I'm just going to go directly to this one. This is pretty obvious what is broken. You can see why this would have an error. So show you it's definitely broken. So, broken, division by 0. This it's a little bit harder to see because it's happening somewhere inside the function. Well, it would be nice to be able to jump through here and see why this is failing. And so what you can do is in IPython, you can just type %debug. Technically, usually magics are automatic, so you could even just type the word debug like that. And that will jump you into the last failure right at wherever you are. Though it seems to be struggling a little bit with the WebAssembly. It's probably interacting with the fact that the WebAssembly is also running an async process. But actually, I don't think it cares, so that might be fine. So let's see. So for example, I can print letter P. This is a language you can look up. It's the PDB language. And then you can put any Python you want. So let's just print X. Oops. So, and yeah, it's not happy with the WebAssembly. But if you're not using WebAssembly, that should be fine. Did it work there? No. Okay. Yeah, it's clashing with the thing, but that's fine. Let me go ahead and quit the debugger. You quit the debugger with Q. Okay. And anyway, so you can just jump in and immediately start investigating what's wrong there and jumping up and down the stack, things like that. And instead of even in IPython, you can even just jump into the last failure, which is really nice. You can also set up breakpoints. So Python has a built-in function called breakpoint. So you could just type, let's just see if this works. So let's type breakpoint. That will, this will actually trigger whatever registered debugger, the best registered debugger. So normally that's PDB. In IPython, it actually customizes this and you get IPDB, which is the one that's built into the cells, which unfortunately has the same, it's unhappy in WebAssembly also. And you just push regular enter. There you go. All right. And then just to quickly point out, I just want to move on, so we're not going to switch to a different place. You can actually install rich tracebacks. If you do a rich traceback, this is how you would install the rich traceback handler. I might need to restart this because of my Python thing. Yeah, I'm going to go restart it. So you can install a rich traceback handler. And then whenever you, so in this case, we can write oh yeah, that's right, files built in, sorry. Yeah, so then you could write this to a file. And then the current file is not enabled in WebAssembly. Okay, but if you had done that in anywhere else other than WebAssembly, this would work out. Obviously, debugging in WebAssembly is a little harder. Okay, so this would actually print out a really nice, colorful traceback and you can even tell it to do locals. So this will show locals and it will print out the locals. JupyterLab also has a built-in debugger. So there'll be a debugger button in regular JupyterLab, not JupyterLite. And you'll find it up at the top corner and you can activate the debugger and then you get a visual debugger with a bunch of cells and stuff. Okay. I just want to briefly mention profiling, and then I want to make sure that we move on and do the sequence in sequence in 2. So just to mention for profiling, and we're not going to run this. This is not going to work on WebAssembly. But with profiling, there's a variety of different ways, but one of my favorite ways is to use the tool called Line Profiler. So if you install Line Profiler, then say you have this function and you want to profile it, all you have to do, especially in IPython, which is really nice, you can just do a load extension, which is a load IPython extension, Line Profiler, and then you run this with LP run. This is the command it adds. And then you tell it what function you want to profile with the -f and then the function name, then any chunk of code here. And then it will run that and it'll give you a line by line profile of this, telling you how long each line took, which is really nice. It's I think usually easier to use than the built-in C profile module. I've also heard that fill is useful. I haven't used it too much myself. And Mimray, which is a new one produced by Bloomberg recently, is also something you might want to look in if you're interested in profiling. Okay. So if you are trying to make code faster, always profile it first. Don't make clean, beautiful code, ugly code just because you think it might be faster. Make sure it is something you have to do to make it faster. Okay, let's move on to errors. Nope, no questions. I sort of addressed the one question in passing there about log 0. Okay, we're going to start a little sequence. We're going to technically end with async, but we're not going to really go into async, but that's sort of what we're building toward. But this is a sequence of different things that are very useful in Python, in the Python syntax. So we're starting with errors, we'll go to generators, then decorators, and then context managers. So if you're wondering about those, the decorators we saw earlier, then we'll actually explain what they are here. Okay, so let's look at exceptions. We've already seen them a little bit. There are these things that look like that, zero division error, and they're actually they're a control flow structure in Python. They're not really an error. They're something that it has as a control flow structure. So whenever you perform an operation that creates an exception, then the exception basically bubbles up. It stops the control flow here, and then it jumps to the next, jumps out, checks to see if it's caught. It jumps out, checks to see if it's caught, goes all the way up. And if it goes all the way up to the final user, then you see this sort of standard exception printout, but that's just the standard exception handler. Okay, so for example, I could catch that exception. I could say except zero division error. And now it doesn't do anything because when I hit this, it bubbles out, it gets caught here. It matches this thing because that was a zero exception handler. And then it, I just said, well, don't do anything if it gets caught. Okay. So if I wrote line code here, it will not run. But if I write code here, it does run. Okay, because hit here, jumped out to here, just didn't do anything, and then goes on. Okay. There's also another piece to this. There's also a finally clause. A finally clause will always run. So that will always run, even if this is not caught, even if I erase this. And I do this, the finally clause will still run, even though it just continues to bubble up. So we still get our zero division. That's often very useful. You can put anything in the MRO there. So for example, I could put zero division error, but a zero division error is a child of an arithmetic error. So I could put arithmetic error, and that would still catch. Exception will catch, base exception will catch, and there's no reason to put object because all exceptions are at least base exception. Okay. You should really never do anything except exception or better here. So never say catch exception. Never say catch base exception. This should never be base exception unless you really know what you're doing. And it should never be empty because that's the exact same thing as base exception. And that assumes that you don't know what you're doing and you just wrote except colon. So don't do that. Generally always catch at least exception or better. Base exception is things like out of memory errors, and trying to exit the program, things like that, things you probably don't want to catch unless you really know you are catching them. Okay. You can actually look at these exceptions. So for example, I'm going to catch that exception and I'm just going to print it out. This is its representation, its repr, and I'm able to grab it there. I could create my own new exceptions. Exceptions often have empty bodies because they are really, the thing that's important in the exception is this thing, this sort of inheritance tree, because the idea is that you can pick which one you want to catch. So it's pretty common just to write a little class that does nothing and just subclasses something. So this means if I created my new exception, now I can catch that thing instead of having to catch runtime error. So if this actually threw a runtime error from something else, that wouldn't be caught. And you want to try to catch the most specific exception you can, because you really don't want to catch something you don't expect. this is some for things you expect, given the word expect. Okay. I already showed you the finally. That's the finally. Okay. So, so really, if we wanted to correctly open files, this is what we should be doing. We should be saying try, we should do our stuff. And then finally, we should close it because we really do not want to close that file unless, or we really want to make sure that file will always close. But we are going to show a better way to do this. But if you just say f equals open, do stuff, and then call f.close, that do stuff could throw an exception, and that could stop you from calling close. If you're on Windows, that will really matter. Someone asked, is there a difference between raise my new exception and raise just without that? Actually, no. Python, because Python will, if you leave the parentheses off, it will actually go ahead and just assume that you wanted to create an instance and not just raise the class, because that doesn't make any sense. So it will actually do the same thing. It will just sort of basically inject those parentheses for you. Because otherwise that would be like a class error or something. It would be a different type of an error, and you really wouldn't, that would be weird to have trying to raise an error and then throw a different error. So it basically just is nice for you there. Okay. So, but I would usually recommend the parentheses. So let's move to a different structure. And this is generators and iterators. Okay, so this, we've seen the usage of one of these. Range, we sort of loop over this thing and we print out 4 times. What is range? Well, it's actually a custom object. It's a custom iterator. So you'll see if you just print it out, it's an object. It's not actually, say, a list or something. So what Python is doing is whenever you have a for loop, what it really does is it calls the iter on this. Iters often return the same thing, but that's important in case you need to have some sort of setup for your iterator. So I can show you it. So this is now a range iterator. And then if I call next, I get 0. If I call next again, I get 1. I get next, I get 2. Next, I get 3. And then finally, if I call next the last time, that will raise a stop iteration exception, which might not make PyDide happy. Usually those things don't bubble out. Okay, but the very last time it will raise a stop iteration. So again, the WebAssembly version is not very happy with it raising that. It must be caught somewhere else. That's fine. That's the only time we're gonna look at this. Okay, we could define our own iterators. There's actually a way to do this with Dunder methods. You could do iter and next, but there's a really nice shortcut for doing this. It's a built-in syntax shortcut. It's quite powerful, and this is this yield. So whenever you see one or more yields in a function, then that function is now is not a function anymore. That's a generator. So, and in this case, it's a iterator is simply a version of a generator that you can't send values into. It's one that only produces values. So for most of our cases, most of the time, most of our generators are iterators. So, because it does actually have a two-way communication protocol too. So this is a generator object. We're going to call it an iterator because it only takes values out. And we can iterator just the same way as we did with our range, and we basically created the same thing. Many of the functions in Python take iterables. So list will take an iterable. So list is how you turn a generator into or a iterator into a list of values. And in fact, if you like list comprehensions, which is this really nice thing in Python where you put this inside brackets and then you have the value and then you have the loop and then it just does this sort of in place. Well, there's actually a generator comprehension too. This thing is a generator. So this thing now is something that hasn't produced all 4 values yet. It's just waiting to produce values. Okay. Some generators can be restarted. So range supports that, but not all of them can be restarted. So sometimes you can only call that iter one time. Okay, you can actually factor out generators. This wasn't originally possible, but this was added a while back, 3.3, I think. Since one important feature of functions is that you can take any chunk of code inside and then factor it out, then you need to be able to do the same thing with generators as well. And so this was added finally as a syntax feature. You can say yield from. So this will yield 0. It will then give control over to this thing, and that will yield 1 and 2. And then it will come back and it will yield 3. And even if you're using the two-way communication that I talked about, this will work still. It's actually really tricky to write this. It's obviously a little easier if they are guaranteed to only be iterators. So I could write for item in middle 2, yield item, and that would do the same thing. So that one's not too terrible, but if this was actually a two-way communication, that would be really terrible because this would not support that. And it turns out to be about 10 lines to support it properly. But that's quite handy and it's built in. Okay. Oh, I actually wrote that right there. So somebody asked about yield versus return. So let me go ahead and just point that out. Let's go back up here. If you have any yield inside of a function, that will turn it into a different type of a thing. So def thing. So if I say return none, so I'll just show you that that is, I'll just print out thing, that's a function. Now, if I say, this is gonna be a little weird. If I write yield none, that actually wasn't quite what I thought. Hang on. So I think maybe I do have to put it first. I thought I could just put it anywhere. Okay, I guess it does have to be before the last return. Okay. So I'm not seeing what the type is there. Let's just make it an error. So let's do list thing. Okay, there we go. So you can see that that's actually a, that's what I have to do. I call it, sorry, there we go. That was working. Generator object, okay. It is a function, but it returns a generator. So now if I take this yield, and even if I stick it after the return, that's still a generator object. If that word yield appears anywhere in the body, that will turn it into a generator. A generator is something that it returns something that can be iterated over. It does not return what a normal function would return. That changes the return. So if you want this sort of thing, you can add the word yield to start yielding things. If you're curious, the thing actually just is an empty list. List. This thing is an empty generator, so it'll immediately return. So that is actually sort of one of the ways you could write an empty generator. It's actually kind of hard to write an empty generator, just because there is no way to just have an empty body in, but still tell this thing it's not a function, it's a generator. But if you add yields, that's for a generator. And you can return from this when you're done, because if I just said return, that's how I could stop this. So I could say if something happens, return, and that would quit the generator. But the presence of yield turns this into a different type of a function. Okay. So last thing I want to mention about these, I'm not going to go over it in detail, but there actually is a two-way communication protocol, and there's not really a nice syntax for using them. So this is messy. This is nice. There's a nice syntax for getting the value from this two-way communication. That's really nice. Just say equals to something on the yield. But actually doing it, you have to manually call send. You have to manually catch the stop iteration. There isn't like a for loop version that you can input values into the thing you're putting in the for loop. But so just mention that as well. Actually, I'll mention it one more time later. So those are very powerful, and that's often a really nice way to write code If you have that sort of in your toolbox, there's a lot of things that can actually be rewritten much more simply and easily just by writing a generator iterator and using that. All right, this is a little piece of syntax, syntactic sugar, but it's really nice. We're going to end actually after context managers. And so this, whenever you see this at and then something before a function or a class, really all that's doing is it's defining that function or class, and then it's just calling that thing with the at, and then assigning it to itself. Okay, so you don't even need to return a function from a decorator, though people will not like it if you do that. So I stick this decorator on F, and you'll see F is just 2 because I returned 2. So not a good idea. You really should return func. So now that's normal.
Yeah. Just say you got about 5 minutes. It's now. Yeah.
Okay. We'll stop at context managers. So, yeah. And I won't go through all the way through this. So I think we should be able to do it in the last couple minutes. Okay. So so this is actually very powerful because this syntax is really ugly. Setting a function equal to calling something that returns a function. People don't really like doing that. It seems a little bit weird in Python to be passing functions around to other functions, returning functions. But sticking a decorator on is very nice and clean, and it reads very well. So for example, here's one that's built in, static method. You stick static method on top of a method, and notice there's no self here anymore. Now you can just basically stick a function inside, and it never has access to self. And in fact, you can call it on the object, just like you'd call a normal method. Well, preferably if you use the right letter here. And then you can actually call it directly on the class itself because it's static, it doesn't matter. So that's an example of a decorator, instead of having to try to write this yourself and handle what the different selves could be and all that. The LRU cache is another really nice decorator. This will actually cache the function by its contents. Though the first time seemed too fast. Okay. And then single dispatch is another. There's lots of really nice decorators. You saw a class decorator. A lot of libraries have actually been built around this idea. Now, just to finish up, let's point out context managers, which are one of my favorite features in Python. And there's a ton of really nice context managers in context lib. So whenever a context manager runs, it runs something when you enter here, and then it runs something when you leave the block at the end. And it's able to handle exceptions. And that's all it does. It can't run the code inside multiple times. It can't tell the code inside not to run. It can't do any of these things. All it is a run this first and then always run cleanup. Even if an exception passes, it can run cleanup. Okay, so for example, one decorator here is the suppress, and this suppresses zero division errors because I passed this in. So you might like that better than try and catch and pass, or try, accept, and pass. Another one that's very common is a timer decorator. Timer context manager. So there's actually this nice tool for writing context managers using iterators. So if you pass it an iterator, the first iteration will be the startup, and the last iteration will be the cleanup, or second iteration. So now I can write a timer, and this will time how long this takes. But this is not hooking into the WebAssembly thing correctly. Okay, and then I can use that timer as a decorator on a function too, because that's a handy feature given to you by the context lib. Okay, so that's a really powerful thing to have. That's a shortcut for writing them. You can also write them using dunder methods and stuff. And this is actually building toward, but we're not going to cover async. So async actually uses all of these things we talked about. And then they initially implemented this using generators, two-way generators, and all of these things we saw. And then they eventually made a separate, syntax for it. This time they fixed the problem. Notice that we didn't write generator or some special keyword there that just magically changed based on the word yield being present. Well, with async, they actually added an async word. It doesn't magically change based on the word await being present. But anyway, that's sort of where that builds to. Eventually, I will be adding, probably after Python 3.11 is out, an async section, because task groups are really, really fun. All right, any last questions? So somebody asked about what WebAssembly is. WebAssembly means it runs on your machine. It's not running on someone else's machine. This is running literally in your browser, just like JavaScript would. So there's no requirement that it runs somewhere else. You're running it. So that's really nice. It does have some quirks, especially due to with threading and exceptions and stuff, because it's translating. It's having to handle sort of JavaScript-like stuff. But it's really, really nice. You notice it just started up instantly and it wasn't running on someone else's machine. But it is still a bit more limited than running it on someone else's machine and having traditional hardware. It's also platform independent. WebAssembly is a single target, so we don't have to compile things for multiple things. You just compile it for WebAssembly once. Any other questions? All right, I think that's it. Feel free to look through the rest of this material. There's a lot of other good things here. And I do keep this stuff updated, so feel free to come back.
Thanks so much, Henry.